Hey there. Today we're diving deep into the epic battle between two computing giants, Google's TPUs and Nvidia's GPUs. And I'm talking about the latest generation. Google just announced their Ironwood TPU 3 days ago, and it's a game changer. These aren't just chips. They're the engines driving everything from ChatGPT and Claude to Google Search and Gemini. Whether you're a developer choosing infrastructure, a student learning AI, or just curious about technology, understanding this battle will change how you think about artificial intelligence. Let's break down what makes each one special, and more importantly, which one you should actually use. First, why do we even need specialized hardware? Here's the reality. Modern AI models like GPT-4 or Gemini have over 100 billion parameters. Some even exceed 1 trillion. Training these models on regular CPUs would take literal years, and that's not an exaggeration. AI is fundamentally about matrix multiplication, billions and billions of simple math operations happening simultaneously. CPUs process tasks one after another, which makes them terrible at this. That's where GPUs and TPUs come in. They're designed for massive parallel processing, doing thousands or even millions of calculations at the exact same time. The AI chip market is now worth over $200 billion, and it's growing exponentially. Every single day, billions of people interact with AI powered by these chips. But here's the fascinating part. GPUs and TPUs take completely different approaches to solving the same problem. One prioritizes flexibility, the other prioritizes specialization. Let's start with GPUs, graphics processing units. Here's a fun fact. These weren't originally designed for AI at all. They were built to render graphics for video games. But around 2012, researchers discovered something incredible. The same parallel processing that makes games look beautiful also makes them perfect for training neural networks. Nvidia's latest H100 GPU packs over 14,000 programmable CUDA cores that can all work simultaneously. Think of it like having 14,000 tiny calculators all solving different parts of the same problem at once. The even newer H200 model comes with 141 gigabytes of memory. That's enough to hold massive AI models entirely in one chip. What makes GPUs special is flexibility. A single GPU can train your AI model in the morning, run scientific simulations at lunch, render a Pixar movie in the afternoon, and still play Cyberpunk at night. They're the Swiss Army knife of computing. They're also everywhere. AWS, Azure, Google Cloud, every major cloud provider offers them. Nvidia has spent 15 years building CUDA, their programming ecosystem, so there are thousands of libraries, tools, and frameworks ready to use. If you know Python and PyTorch, you can start using GPUs today. This accessibility is why GPUs dominate about 80% of the AI accelerator market. Now, TPUs, tensor processing units, take a radically different approach. Instead of being a Swiss Army knife, think of TPUs as a specialized chef's knife, designed for one thing and absolutely perfect at it. Google designed these from the ground up specifically for the tensor operations that dominate neural network computations. They use something called systolic arrays, specialized circuits where data flows through processing elements in rhythmic waves, kind of like blood pumping through your heart, hence the name, systolic. And here's the big news. Google just announced Ironwood, their 7th generation TPU, 3 days ago, and this thing is a monster. It delivers a 10x performance improvement over their V5P generation, and it's 4 times better than Trillium, the previous generation. But the scale is what's truly mind-blowing. Ironwood SuperPods can connect 9,216 chips together with 9.6 terabit per second interconnects. Together, these chips access 1.77 petabytes of shared memory. That's 1,770 terabytes. To put that in perspective, every book ever written in human history could fit in that memory about 35 times over. Google Photos processes over 100 million images every single day using TPUs. Google Search, YouTube recommendations, Google Maps, all powered by TPUs. And every Gemini AI response you get, that's running on TPUs too. The catch? They're exclusive to Google Cloud Platform. You can't buy them for your own data center, and you can't use them on AWS or Azure. It's Google Cloud or nothing. So let's talk numbers. How did they actually compare? For raw training and inference performance, Ironwood's 10x improvement puts it in a league of its own for AI-specific workloads, and Google claims it's their most powerful and energy-efficient TPU ever built. But Nvidia isn't standing still either. The H200 can crush through 31,712 tokens per second when running the Llama 2 70B language model, compared to the H100's 22,290 tokens per second. That's a 42% improvement. Energy efficiency is where things get really interesting.
TPUs typically consume between 175 and 250 watts per chip. High-end GPUs like the H200, they can hit 700 watts. That's nearly 3 times the power draw. When you're running thousands of chips, that difference in electricity costs becomes massive. For AI-specific tasks, TPUs generally deliver 2 to 3 times better performance per watt. But here's where GPUs fight back: memory. The H200 packs 141 gigabytes of memory in one chip. This means you can fit larger models without having to split them across multiple devices. TPUs solve this differently. They share memory across thousands of chips, which works brilliantly for distributed training, but requires different optimization strategies. And here's the validation that matters. Anthropic, the company behind Claude AI, just committed to scaling up to 1 million Ironwood TPUs. That's not a typo, 1 million. They're betting their entire future on this technology. So which should you choose? The answer depends entirely on what you're building. Choose GPUs if you need maximum flexibility. If you're a startup or researcher experimenting with different models, if you need to deploy across multiple clouds, or if you want the matured ecosystem that CUDA and PyTorch provide. GPUs are also your only option if you're not on Google Cloud. With an 80% market share, they're the safe, proven choice. Choose Ironwood TPUs if you're all in on Google Cloud, you're training frontier models at massive scale, or you're optimizing for cost efficiency and production inference. If you're running workloads with TensorFlow or JAX, TPUs are optimized specifically for those frameworks. Companies like Anthropic, Lightrix, and Essential AI are all betting on Ironwood for their next-generation AI systems. Here's the interesting reality. Many large organizations don't just choose one. They use GPUs during development for flexibility and rapid iteration, then deploy on TPUs for cost-effective production at massive scale. It's not GPU versus TPU, it's GPU and TPU. The AI hardware race is just getting started. We're in an incredible moment where both technologies are advancing at breakneck speed. Google just dropped a 10x improvement with Ironwood, Nvidia's Blackwell architecture is coming soon, and AMD is pushing hard with their MI300 series. For you, the bottom line is this: if you're just getting started with AI, begin with GPUs for their flexibility and ecosystem. But keep a close eye on TPUs, especially Ironwood, because they're reshaping what's possible at scale. The future of AI won't be powered by CPUs. It'll be powered by specialized silicon designed for one purpose: making artificial intelligence faster, cheaper, and more accessible to everyone. If you found this deep dive helpful, hit that like button and subscribe. And if you want to learn more about AI infrastructure, check the links in the description. Thanks for watching, and I'll see you in the next one.